Well, good morning to the lecturer. Today we are exploring the fundamental role of control system, which serves as the regulatory backbone for physical components to ensure that they meet um, that they achieve precise and desired outputs. By leveraging feedback loops, we can fine-tune a system's stability, accuracy, and response speed to meet rigorous operational demands. Our engineering analysis will focus specifically on time domain performance, where we measure critical metrics such as peak time, settling time, percentage overshoot to define a system's success. To bridge the gap between the theory and reality, we utilize industry standard tools like MATLAB and Simulink for high fidelity modeling and simulation, ensuring a total system reliability before interpretation. Thank you. So now I'll be talking about the objectives of this assignment that has been given to us. The primary goal of this study is to conduct a comprehensive performance and stability analysis of a unity feedback control system based on a third order transfer function with a gain of k is equal to 100. Our methodology bridges the gap between the theory and application by first utilizing analytical formulas to predict transient characteristic, specifically peak time, settling time, percentage overshoot, and then verifying this result through high-fidelity MATLAB and Simulink simulations. Furthermore, the project evaluates system reliability by accessing stability through both the Routh-Hurwitz criterion and pole zero mapping to ensure all poles reside in the stable region of the S-plane. Finally, we analyze and verify the steady-state error for the step RAM parabolic inputs to confirm accuracy of our system modeling against standard theoretical expectation for a Type O system. Thank you.
Okay, for the methodology, the analysis of the unity feedback control system was conducted using a dual-phase approach, theoretical analytical calculations, and software simulation using MATLAB or Simulink. This systematic process ensures the accuracy of system performance and stability evaluations. Okay, this slide shows the manual calculations for our control system. First, we find the open loop transfer function and then calculate the closed loop transfer function. From this equation, we determine the system poles. The poles are one real pole at negative 12.825 and two complex poles at negative 1.587 plus minus 3.572J. These poles are shown on the S-plane diagram, which help us see how the system behaves. Next, we calculate the system parameters such as natural frequency and damping ratio. The damping ratio is about 0.406, which means the system is underdamped and shows some oscillation. Finally, we'll calculate the time response values like peak time, settling time, and percentage overshoot, which is about 24.77%. Overall, this manual calculation help us understand the stability and performance of the system.
Assalamualaikum. My name is Muhammad Afzal bin Muhammad Idris. For the MATLAB simulation part, as we can see, we have used our MATLAB commands to obtain the graph for closed loop step response. In the closed loop step response, we can see all the plotted points for rise time, settling time, final value, and also the peak time. These are the main objectives that for the MATLAB simulation part, as we have to gain all these points. For the comparison of results of simulation and theoretical, as we can see for the peak time, the difference is only slightly different, around 8.75% error only. For the settling time, we can see 1.151% error comparing both simulation and theoretical. Last but not least, for the percentage overshoot, we can see for the simulation we have gained 23.5%. For theoretical, it is 24.77%, which shows only 5.13% of error.
Okay, for stability analysis, we use the Routh-Hurwitz criterion. It is because to determine system stability without explicitly solving for the system poles. According to this criterion, a system is stable if all elements in the first column of the Routh array are positive. For visualizing stability, the pole zero map show that the location of system pole in the complex S-plane. The system has one real pole and one complex conjugate pole pair. All poles are strictly in the left half plane, and the complex pole indicate the system will have an underdamped oscillation before settling, but it will never go out of steady-state error analysis. For a type 0 system, the error for a RAM input increase without bound with time. Therefore, a type 0 system has infinite steady-state error for a RAM input, which is confirmed by simulation. The simulation result closely matches the theoretical value, confirming the accuracy of the analysis. For a type 0 system, the steady-state error for a step input is finite and non-zero. This occurs because the system does not contain an integrator, so it cannot completely eliminate the error. Theoretical analysis yields a steady-state error of 0.490, which is verified by simulation, which is 0.4898.
we move on to the discussion part. Okay, for all system poles lie in the left hand side of the S-plane, confirming the system is in the stability position. So for the complex poles, indicate underdamped and oscillatory behavior. Okay, for the third discussion, the theoretical and simulated peak times are close, showing a fast response to the system, and also settling times from both methods indicate quick stabilization, and the theoretical and simulated overshoot values closely matches to the values that we get, and also the theoretical and also the simulation. And lastly, the minor differences are expected due to modeling and simulation effects. For the conclusion part, all objectives were successfully achieved through theory and also the simulation from MATLAB and Simulink that we done. For the system was correctly modeled and show underdamped but stable behavior at k equals to 100k that we get from the assignment. And for the theoretical and simulation results closely match, confirming analysis is accurate. And also stability was verified by the left hand S-plane post position. And lastly, steady state error results confirm a type 0 control system. That's all from us. Thank you.